Smokeless Chimney presents Smoke Measurement, Opacity Light Theory, Light Side, Sensor Side, Chapter 3. To measure smoke, the best method is to have a light source and a sensor. You pass the light beam through your media, and the light that doesn't hit the sensor is your opacity measurement. The light that makes it through is your transmitted measurement. This is a diagram of a opacity system. It starts out on the right with a light source, a lens, a light port. In the circle in the center is the media that you're trying to measure, in this case smoke. So your light beam is traveling through the smoke, and when it hits the smoke particles, some of it doesn't make it to the light sensor on the other side. The light red and is missing is the opacity measurement. These are light sources. The two on the left are LEDs. The three on the right are diode lasers. To energize these light sources, you need a very stable power supply. We found that using a constant current power supply is better than a constant voltage power supply. This is my current power supply setup. These are two constant current power supplies. You can see that the CC light is on. And this is a white LED, the flower arrangement, and a little glue to keep it in there. And here we see the light being projected across to the port on the opposite side. There's a lot of stuff in this image. However, what I want you to focus on is these two power supplies. Here we have a power supply setup. Notice the CC light is red. It means it's doing current control. Now this is powering up a laser, which only uses 0.035 amps. Now that we've done the light side, let's talk about the sensor side. This is a diesel automotive opacity sensor. Light side, sensor side. This is a sensor. It is a high range dynamic RGB color sensor. Right in the center of the chip you see an LED light. Well, just to the right of that is the light sensor. I'll move it around a little bit. You can see the actual model number. It's a TCS34725. It's maybe 15 millimeters by 15 millimeters, and you have to hook up 4 wires to it. This is the setup before I realized that constant current was the way to go. I have two constant voltage power supplies on the left, and I'm evaluating a constant current source on the table there. And we have a white LED, and we're trying to figure out how much power to put in the LED. In this case, the LED got rather hot. What we're finding is that the temperature of the LED impacts how much light it generates or how much current it flows. Therefore, either measuring the temperature of the light source will help us stabilize it further. In summary, if you got a very stable light source and a stable sensor, you can do opacity measurement. Smokeless Chimney, warm homes and clean air for everyone. www.smokelesschimney.com